Hello everyone, and welcome back to Fusion 360's live stream. I am your host Jason Lichtman, and today we are going to be talking about a topic that is near and dear to my heart, Kerf. If you've never heard of it, Kerf is the width of a beam, and that could be a laser beam, it could be a Waterjet stream, and it could also be a plasma table beam as well. And so the question we're going to answer today is, what is Kerf? How do you measure Kerf, and how do you compensate for Kerf? And actually, why do you need to compensate for Kerf? So we're going to cover all of those topics, and everything that we talk about today is going to be applicable to both a Waterjet, a laser cutter, as well as a plasma table. So regardless of which one of those you are in particular interested in, I think you're going to learn quite a bit today. As always, we have our co-host Aaron Magnin on the live stream. So if you have any questions, please feel free to ask them away and he'll be able to answer them. And anything that he can't answer, I am happy to answer after the live stream. So let's jump right into the good stuff. On my screen today, you could see a piece of wood. And this is the kind of thing that you might do in your backyard or maybe even in your professional wood shop. But what we're going to do is we're going to cut this piece of wood. And by the way, this is going to be an example that's going to explain properly what Kerf is and why it's important. So if I wanted to go and cut this wood, first thing I'm probably going to want to do is to make a marking. You could see this line right here of where I want to cut. But in addition to that, in real life, I'm probably going to want to go and make sure that I know which side I want to cut on. So let's go and add that. Here you could see an X for the side that I don't care about, and a check for the side that I very much do care about. Now let's go and put this on a table saw and see what's going to happen when we go to cut it. So here you could see I have a table saw blade in place, and it's centered exactly on this line. So if we go and zoom in here, you could see it's centered on that line. And I bet you guys can figure out that if I started to cut in exactly this setup that I have here, I'm going to have a problem. Because right now, I'm wanting this thing to measure from this end to the cut 30 inches. But because of that blade, or rather because of the width of the blade, the resulting part that's going to come out of this after I cut is going to be far less. And the reason is because the blade itself is going to cut material away. And that is Kerf. So the width of the blade is what Kerf is. It's the width of what is cut away when you're trying to create something that you like. And in this particular case, the blade is a 1/4 inch wide. So the kerf of the blade is a 1/4 inch. And half of the kerf is, of course, 1/8 of an inch, or half of a 1/4. Let's go and put this into perspective, because I said that we were going to be talking about Waterjet, plasma, and things like that. And this example is not exactly like that, right? Because a table saw, of course, is going to cut straight lines, and with a Waterjet or a laser cutter, you're going to be able to cut really intricate shapes. So let's go and look at an example and see what's going to happen in that example. Here you could see I have what I call my Kerf tester. It's a small block of wood that has an outer shape of a square, an inner square, you could see that right here all the way around, and then it has a little marking for alignment, and then it has some markings for text. But in short, this is a pretty typical, basic part, and for me, this is how I'm going to be able to tell whether how much my Kerf is going to be. And we'll get into that later and explain exactly how to be able to calculate the Kerf, but let's go and show you an example of what we're talking about. If I go to cut, let's say this inner square, and let's go and simulate this real quick using Fusion 360. I'm going to hit the play button, and in a second here, you're going to see the beam of the laser or the Waterjet. And you can see that right here. That's the yellow circle right there. And I'm exaggerating this just a little bit so you could see it a little bit more clearly. And if I hit play, you're going to see that this laser beam is going to go around my square. And just like we talked about with the table saw, it's going to have a width to that beam. And so the resulting part is not going to be exactly what I intended. Let me actually show you this in person real quick. So here you can see me again. This is a pretty simple part. So this is similar. So this is a long rectangle. And all I did here was I cut the outside shape with my laser. I happen to have a Glowforge at home, and so I get to do this in my very own home. Pretty awesome. And so I cut the outside shape, and then I cut a square in the inside. And the key here is that the beam, although it's really thin, does affect the results. So if I hold the outer and I start to jiggle the inside, there's a little bit of movement there. And that movement is caused, again, by the width of the beam. If I'm doing a more complex project, and it could be something even as simple as this. So this piece here is using tab and slots, and it's important that the fit be perfect, right? And so if I'm not doing anything, any kerf compensation as we call it, and I laser this, the laser beam width is going to affect the fit, and all of these parts are going to be a little bit loose. And I'm going to illustrate that in a second on the computer. But I wanted to show you practically that you can actually feel the difference, even with something like a laser beam that's really narrow. So here we are back on the screen. And what I was showing you a second ago with this yellow circle running around, and again it's exaggerated for the width, is what would happen if you actually ran the laser on the intended size. Let me show you what it would look like if you do something called kerf compensation, which is to adjust your file to match the width of the laser beam. Again, this is going to be exaggerated so that it's easier to see, but let's go and simulate this. And here you could see that my goal is actually to cut out this big square right here, but the blue line indicates the path of the laser itself. And the reason is because here you could see, let's go and slow that down, that we've adjusted the path of the laser so that the outer edge of the laser beam is going to make contact with the square that I'm cutting. And if this is done, the result is going to be that you get parts that fit perfectly. Let's go and illustrate this another way to make this really drive home for you guys. So we're going to go jump over to Adobe Illustrator, and here I have the same file. Right? So the blue is the outer shape, the red is that inner square, and if I zoom in quite a bit here, let's go and zoom in some more, you're going to see in just a second what we call a stroke in Illustrator, which is going to simulate the width of the laser beam. So if this red dark line here is my intended path, the lighter pink line is going to be what's actually incinerated by the laser. And there is a width to it. Again, that's the kerf. But if we look at this even further, let's go and show you this with some labels, and we'll zoom in even further. Here you could see that the entire width of the laser beam is called that full kerf, or just kerf, and then half of that distance is the half kerf. So let's talk a little bit about how we can actually measure it in real life. So this file is the perfect way to do that. Oh, hold on just a moment. There we go. So the goal here is going to be to take this file, which I've already uploaded to YouTube. There's a link there so you can go and download this. And you could download it in SVG format, in DXF format, and also Illustrator format. And I also included the actual Fusion 360 file, so also the Fusion 360 format, which of course is the one I recommend, but choose whichever format works for you. And I created those files in both metric, which is the units that I recommend, and I also put it in Imperial, which you are free to use at your leisure. So download whichever file works for you, and I'd recommend you run it on your laser, or run it on your Waterjet, or run it on your plasma table. And here you could see the actual part. And it's rather small. Let me get rid of, no, it might stay. There we are. So this is the part. And what I do is I laser this without any kerf compensation. So I laser it as it's intended. And as you could see in the center, that small square is intended to measure 10 millimeters. And I even have in the text here that once you make this little piece, take it out, the inner diameter of the square should measure 10 millimeter. And the difference, or the delta, as that little triangle represents, is equal to the kerf. So what you're going to do is you're going to laser that part, or Waterjet it, take your handy calipers, and you can go and measure the width of this piece. As I mentioned, it's intended to measure 10 millimeters. And what I'm seeing on my calipers is actually 10.1, well, hold on, I gotta hold that properly. Let's do that one more time. There we go. A little hard left-handed, but 10.19 millimeters. Now, I do recommend you also measure it vertically, right? So there's the width of the square and the height of the square. Both are intended to be 10 millimeters, but measure them both. And here I have 10.21 millimeters. Very close, but not exactly the same number. In addition to that, you could go a little bit further, and you could also measure the width of the little square here. This one's going to be undersized. And so this is 9.79 millimeters. And I do recommend you also measure the height. Try that again. There we go. Left-handed. And now I have 9.87. And again, the difference between 10 millimeters in this case and the number that I see on my caliper, that is the full kerf that we talked about. But there were different measurements in the vertical direction than the horizontal. And there are a couple of reasons for that. One is I'm lasering wood in this case, and wood might not have perfectly uniform properties in either direction. Also keep in mind that the travel speed of the head of the laser, even though it's intended to be the same in both directions, could actually be slightly different. So you're going to want to go and take those numbers, and you're going to want to go and write them down or type them into some system that you can record. And I would recommend recording all those numbers, the vertical height, the width, and pick the maximum number as well as the minimum, and use that delta and record all of it. And the reason you're going to do that for all the numbers is because you can actually have different kerf numbers depending on the project. So if you think about it, without any kerf compensation at all, right, if you just laser exactly on the 10 millimeter square, you're going to get an inner square on the bigger piece that is oversized, and you're going to get an outer diameter on the smaller piece that is undersized, right? And when you put them together, you're going to get that jiggly fit that I showed earlier on that other piece. You're going to get that little jiggle. Okay, so if you do kerf compensation, ideally you're going to get a perfect fit between the two different parts. But perfect fit is subjective, right? So what you can do is you can actually have different kerf values for different types of fits. The higher the kerf number, the tighter the fit's going to be. So I would go and measure the kerf, and you saw earlier that I got 0.18 and I got 0.21. I would set the 0.21 to be the really tight fit for the kerf, and I would set the 0.18 to be, let's say, a medium fit. And then I'd probably pick a number that's just slightly smaller and make that a slightly loose fit. And between the three, you're going to be able to go and get any kind of fit you want on any project. Now, I should tell you that the kerf itself can change depending on the material, and depending on the thickness of that material, and also depending on the settings that you're using on your Waterjet, your plasma table, or your laser. So really, step number one should actually be to figure out what settings you want to use in your machine to actually cut through your part, right? Because until you get it to cut through your part the way you like it, the kerf really doesn't matter. So step one, figure out the settings on your machine. Step number two, laser this part, right, using this template that I am providing, and measure that kerf and write down all those numbers. And then step number three is going to be to use those numbers to compensate for that kerf. And I'm going to show you how to do that in just a second. Now, I just want to repeat that the reason that we're measuring the width here is to figure out that kerf. But some people might say, when you measure the difference between 10 millimeters here and the size of that square, why is that in particular equal to the kerf? So let me go and show you that. So in a second, you're going to see Adobe Illustrator again. Remember how when I showed this image, I showed that the full width of the beam is that full kerf, and this is half of the kerf? Well, don't forget that what we're really measuring here, when we measure the difference between this outer edge and the intent, which was this middle, is we're measuring this half kerf on both sides. So when you go and measure this as 10 point, let me go and so you can see me, just 1 second here. There we go. So when you go and measure this part and you measure it as 10.18, and you subtract 10, the 0.18 is equal to the half kerf on both sides combined, right? And that means the full kerf. And when you're actually doing the offsetting, you'll see that in just a moment, you're going to always offset by half kerf. right? So you're going to write down all the numbers for the full width of the laser beam, and when we do the offsetting, we do it for half, and you'll see that in a second. Just as a reminder, when we were in Fusion 360 here, and I was showing you this compensation like this right here, let's go and show that one more time. The laser itself is moved over by, again, that half curve. And you could actually see this on that first example too. When we go and we look at this table saw, if I wanted to make sure to cut this properly, what I'm really going to go and do is I'm going to go and adjust the curve by half of the width of this saw. And you could see that here. This is the line in the very center. This was the intended cut. And I move over by half of the blade, and you can see that the blade is cut literally in half by this line, and that would give me exactly what I'm looking for. All right, so that would be absolutely perfect. Cool. All right, so there are a couple of different ways you can compensate for kerf once you know it. The first way is going to be in Fusion 360. Let's go and take this example here, and we're going to go in the design workspace. And here you're going to see that I have a sketch for this particular design, and all of these are fully constrained sketches, and I can come in here and I could change this. And hold on just a moment, let me get this start menu out of the way. There we go. I can go and edit my sketch, and I can add an additional sketch to it. We can go and use an offset here, choose my particular sketch, offset this out or in, depending on what I'm trying to do. In this case, I'm going to go and offset it out. And for the value, let me go and move this start menu again out of the way. Nope, that's really, give me just 1 second, actually just go and fix this. There we go. Now we could have proper live stream. Nope, still not fixed. We're going to leave that. So for this value here, I'm going to go and type in the kerf divided by 2. So in this case, let's say 0.09. And again, the difference is really small on a real production laser or a production Waterjet or a production plasma table, but this is going to be an important distinction. You can take this sketch and make it construction or not, and then later on, when you're going to send this data out to your laser or your Waterjet, instead of using the outer edge of the geometry, you can actually use the outer edge of this sketch. And this is going to be a kerf compensated sketch, because I took the original shape and I compensated for half of the kerf by making this one bigger. And on the case for the square in the middle, we'd go in here, grab this same square, and this time we're going to do an offset, and we're going to go in by 0.09. Perfect. Now, as you could tell, I'm probably going to end up having to do this quite a bit. So if you're going to be using the method that I'm showing you here by adjusting the sketches, what I would recommend is you go into your parameters table in Fusion, under Modify, change parameters, and here you can go and add a new parameter here called kerf. Type in the value that you figured out by measuring, in this case 0.18 millimeters. And then I could even add another one of these parameters, and this one's going to be called half kerf. And this one is going to be equal to kerf divided by 2. And hit enter. Now, when I go into my sketch, instead of having to type in the value every single time, we'll go to this one here. I could type in this case, minus for the direction, and then start to type in half kerf and hit enter to select that particular variable, that parameter. There we are. And now if I ever needed to change the kerf, instead of having to go and hunt and find every single sketch that's using that particular value, instead I can go into my parameters table, change this value from, let's say, 0.18 to 0.1, and it's going to go and adjust in every sketch that uses that dimension. Cool. Now, when I'm ready to actually send this over to the laser or the Waterjet or the plasma, one of the ways I could do that is to right-click on the sketch, save this as a DXF, and then I could use any software I'd like to actually run the laser. All right, so this is method number 1. Another method you could use is, instead of actually adjusting your sketch, let's go and edit this original sketch, and I'm going to get rid of these particular lines that we added, the kerf compensation lines. Perfect. So option number 2 is you take the sketch as is, And you do the same thing, like save it as a DXF, and you do the same thing in another software, whether it's Illustrator or Inkscape or some specialty CAM software that came with your particular Waterjet. You can go and do that there. But I think what you're going to find right off the bat is that there's a whole lot of inefficiency here. Because if you're going to be saving out this as a DXF, making the changes over in another program, guess what's going to happen when you end up having to change your design? If you decide that instead of this size, you want to make the size slightly bigger or a size slightly smaller, or you need to change the text, or you need to change anything, you're going to have to go and save a DXF again, and then go into that other program and redo all of your work. That's pretty inefficient. So the first option is definitely preferred between option 1 and 2. If you were going to go the sketch route and make changes to your sketch, I do recommend you do all of that here in Fusion. And again, you can just select whatever edge or sketch entity you want, use the offset command, choose inside or outside, and then type in the value, in this case, for half kerf, and use that parameter to automatically drive things. That'll certainly be more efficient for you. But the best option, let's go and delete this, and I'm going to get to show you the best option. The best option is to design everything you'd like in 3D inside Fusion, just like you see here, and then use the manufacturer workspace in Fusion to drive your toolpaths, including your kerf compensation. So let's go and show you how to do that. We're going to go from the design workspace over to the manufacturer workspace. And here I have quite a few things already set up. I'm going to go and just regenerate the toolpaths, and I'm actually going to go and show you how to do this from scratch. So the first thing we need to do is to set up our kerf. So earlier we used a parameter to drive kerf, and here we're going to use what we call tools. And the tools are going to be the laser or the Waterjet or the plasma beam, either one. You're going to go to the tool library. You can create a new library for yourself, and here you're going to see that I have one for my Glowforge laser. And here you see that I have 3 different laser beams. I have a 0.18 millimeter laser, that's a 0.18 millimeter kerf, and this is specific to my material and based on the fit that I want. So I have this called medium proof grade walnut, which is a material made by the Glowforge people, and I'm calling this the tight fit. Then I have another one here that's 0.1 millimeter, also for the medium proof grade walnut, and I'm calling this a medium fit. And the last thing I have here is one that's called 0.25 inches, and this is a very big cutter, and I'm using this just to illustrate whether I have my kerf compensation set correctly. Just to make sure, is this getting smaller when it's supposed to? Is this getting bigger when it's supposed to? And so I could double check that. So if I wanted to make a new laser beam, all I have to do is say new tool for Waterjet laser and plasma cutting. I get to choose whether it's going to be for a Waterjet, for a laser, or a plasma. Once you choose that, choose your units, whether it's millimeters or inches. I know that I'm biased and I prefer millimeter, but you could use whatever works best for you. And then here is where you're going to choose the kerf width. So if I were making one of these for the piece that I just made, that was this one right over here, I'm going to go in here and choose millimeter, 0.18 millimeter, and I should be good to go. The only thing I need to do that's in addition is under general, I would recommend you put in a description. So in this case, it could be, let's say, medium proof grade cherry, because that's the wood that I have here. And this is going to be for a tight fit. Perfect. And now I have that. And I'd recommend you make as many of these as you need. Again, it's based on the material, the thickness, and your settings, as well as, of course, what kind of fit you want, whether it's a tight fit or a loose fit or a medium fit. So 0.18 is great for this particular application for a tight fit. 0.1 is pretty good for a medium fit. And anything between 0 and, in this case, 0.1 would be good for a loose fit. In fact, you could use 0 and that would give you a loose fit already. You just get to control how much of a loose fit you want. So there I have my lasers. So to create toolpaths in Fusion, it's really easy. We're going to go and choose a 2D profile. Make sure to select the tool you want to use. So here you're going to have from that list, and I'm going to go and choose that new one, the cherry, proof grade cherry tight fit, and say OK. Then under geometry, I'm going to go and choose what I actually want to cut. So let's go and hide that inner square. I'll go and choose this particular edge right there. And then I have some other options here. The most important one is going to be over here for sideways compensation. There are three options: left, center, or right. And I'll tell you the difference. Center is going to give you no kerf compensation at all. It's going to line up the center of the beam exactly on the center of the edge that you selected. Left and right are in this case identical. They're just going to choose, which direction you're going to be compensating, but the result in this case is really the same. It's just like saying turn the compensation on or turn it off. So I'm going to use left, or the right could be fine. And in this case, for my laser, I go to compensation type and I choose in computer. Now when I go and I say OK, you'll see that in just a second. Let's go and zoom in here. If I zoom in pretty closely, you'll see that the blue, which is the path of the center of the laser, is slightly offset in to match so that the beam, the outside of the beam, is going to run along this edge, exactly what I wanted. So if we go and simulate this, let's go and zoom in, zoom out a little bit. We'll zoom in as we need. Let's go and hit the play button and give that a second. There it is. Let's go and zoom in. I'll slow it down so you can see this. And the laser is actually going to follow that blue path, and that outside edge is going to match the inside of that square that we're trying to cut. And that means that if I use kerf compensation, the second piece of this that I cut, right, the second one that I cut with the compensation is actually going to measure exactly 10 millimeters. That's really what the kerf compensation is all about. So this is a great way to do this, right? I get to control exactly how much compensation I get, and the best part is that I get complete, like a two-way feedback or a closed-loop feedback system with my model. So if I end up deciding that I'm going to go and change my model, let's go into the design, and I change my sketch. I can change this to be from 25 millimeters wide to, let's say, 35 millimeters wide, or the height from 25 to also 35, and I could change the size of this particular box to 15 by 15, and everything is not only going to adjust visually on the screen, but it's also going to adjust in the toolpaths. Let's go back from the design area over to manufacture. I'm going to go and regenerate the toolpaths. And here in just an instant, let's go and simulate this one just again. Oh, that's a little hard to see. Let's go and slow that down. And here again, I have that kerf compensation. Even for the bigger size square, right, everything adjusts. So this is a really neat way to be able to adjust for kerf compensation. So far, let's give a summary of what we did so far. We talked about what kerf is, right? And that's the width of the beam for waterjet, laser, or plasma. We talked about why that matters, because if you try to laser or waterjet on, let's say, a 10 millimeter square, the resulting parts are not exactly going to measure what you intended. So kerf compensation is the ability to compensate for the width of that laser or width of the waterjet spray to be able to get you exactly the size that you want. We talked about how to determine what the kerf is, and that was by figuring out the settings you want to use on your machine to actually cut the parts, then cut a sample part, measure the sample part, and take the difference between the intended amount, the intended measurement, and the actual measurement, and that's your full kerf, or the full width of the beam. Then we talked about how to take that and actually use it, how to actually compensate for it. And to do that, there are a variety of different ways. We talked about using sketches to offset your geometry by half of the kerf width. And we also talked about using another program, whether it's Illustrator, Inkscape, or any other program to do the same, which generally speaking I don't recommend. And lastly, we talked about using Fusion 360's Manufacture workspace to do it for you as well. And there you're going to go and create new tools, one for each of the different kerfs you'd like to use. And then all you have to do is create 2D profiles for all of your geometry. Choose the right laser that you'd like to use, or waterjet, so that you get the kerf correct for what you're intending. And make sure that the compensation in the passes tab is set to Let's go and make sure I remember this perfectly. There we go. Under passes, you're going to make sure the sideways compensation is set to left or right, whichever one you prefer, and that the compensation is set to in computer as opposed to in control. Now you might end up working with a particular machine that needs slightly different settings, and that's okay. I'm talking about the general principles here on what works and how it's going to work for you, and so I think that this is going to send you in the right direction. Now, there is one more thing I want to mention before we're done today. This is going to be a shorter live stream than usual. So if you go and you make a product, whatever this happens to be, you want to go and make a prototype of it. So here I have an example. This happens to be something that I was making for myself, but this could be something much more serious and much more industrial, of course. And I want to go and test this out. Now, I could waste a whole lot of material getting the kerf incorrect and getting the fit wrong on this part. And so I want to tell you another idea. And this was brought to me by someone named Mark Evans, who's another fellow Glowforge owner. And he recommends doing something called a Kerfinator. Really neat, a really neat name, I think. And what he says is, instead of making your entire part and hoping that the kerf you're using is correct, why not go and make a small portion of it and test the fit? So here I have a full-size part, but what if I just took a corner? Maybe it's this corner right here, everything that's inside my fingers right now. I chop this off of my design. I laser just that corner with whatever kerf I think is going to be the best. I can use scrap material for that, which is pretty awesome, so I don't have to waste a fresh sheet of new and expensive material. And then using that scrap, I have a couple of different parts. In this case, it would be a small portion of the back, do you see here, a small portion of the side, and a small portion of the front. And I'd be able to see right away how those parts are going to fit. And if I like what I see, then go and laser or waterjet the entire part. And this way you don't waste any material besides scrap, of course. But it's called scrap for a reason, so it's meant to be used for exactly these purposes. If you decide you don't like the fit of the part, then go back into Fusion and simply change the tool that you're using. Let's say in this particular case for this inner square, and change the tool to be a different laser kerf. Right? And I have a whole library here of the different ones that I like to use. And so I could simply choose a different one with a different kerf value, laser that piece of scrap again, and based on the results, decide to go ahead and laser or waterjet the entire part. So that's a really good way to not waste a sheet of fresh material. Again, it's called a Kerfinator. Thank you, Mark. I appreciate your feedback. Cool. So today we talked a lot actually, about kerf. I hope this serves as an introductory of what kerf is, how you can measure it, how you can compensate for it, and how you could therefore use it in your designs. If you have any questions at all about anything that was covered today, please make sure to put them in the chat window. As always, please make sure to also include any comments, especially positive ones if you enjoyed what you saw today. I thank you so much for your time, and I hope that you get to make incredible things in Fusion 360. And with that, I will conclude today's session. Hope you have a great day today. Thank you again.